Okay, so what we did yesterday is we talked about simple interest, which was an arithmetic sequence because you were adding on the interest. Now we're going to look at arithmetic sequences where we're taking away the same amount, the difference. So flat rate, if you want to write this, write that it's an arithmetic sequence. So it's an arithmetic sequence, but where we're minusing same amount, okay? So it's always going to reduce by the same amount every time. So we're going to look at flat rate, and now we're going to look at it in terms of a recurrence relation. So remember this table, this column in the table, because at the end you're going to have a table with all of them together. Okay, so this column in the table shows you the recurrence relation. So if I had to write a recurrence relation for a flat rate scenario, it will look like this, where you'll have your initial amount. So whatever, with flat rate, things like depreciate. So what it means is it goes less in value. So I might buy like a lawnmower, and then, you know, it depreciates in value over years or something like that, all right? So the initial cost is what you bought it for or you get it for, and then you're going to see that it depreciates. So you can see the rule with how you get the next term. It has a minus D, so it's a common difference is getting subtracted every time. So how you calculate that D is that with flat rate, they'll say it's a percentage of the original cost. So say I bought, here, if we look at it, let's go through the example. So the following recurrence relation can be used to model flat rate depreciation. So we're going to get used to underlining that, because remember I told you they have to tell you what scenario or what actual, you know, situation you're using. So this one's flat rate. So this will model the flat rate depreciation of a car purchased for $18,500. So you can see they just told me the VO, and they said that it depreciates at a flat rate of 10% per year. So that could be, they could say that as 10% per annum. So maybe just put that there so you're remembering, if they write 10PA, that's the same as 10% per year. So what they did, they calculated 10% of the original price, and that is your D value here. So they're showing you down here, if we do 10% of, so say for example, so if we did R over 100 times VO, so what they've done is 10 over 100 times the 18,500, and that's how they've ended up with 1,850, okay? So then the questions ask us, we've got use this recurrence relation to find the value of the car after V1, 2 and 3 years. So remember what I said the other day, when they're saying use the recurrence relation, it means I have to show it. So when I'm trying to find V1, it'll be VO minus that 1850, which was actually 18,500 minus the 81850, which equals 16,650. Okay, so then when you show V2, you show the one before, which is 16,650 minus the 1850 again, which is 14,800. Okay, so that one, V2 ends up being 14,800, and then if I want to show recursively V3, I do the one before minus the 1850, which equals 12,950. So you must show that, and it'll only be 1 mark next year, but unless all that's shown, you're not getting that 1 mark. Every mark counts. You don't want to drop down on something easy to do, so let's just do that. Okay, next one, it says, how long will it take the car to be 0? So what that is, they're actually telling you a value. So they go, when will the value of the car be 0? So when we have that scenario, we probably want when we were trying to find like a particular value, we'll want to use the nth rule. And up here in the middle column is the formula for nth rule. So I'm looking up here. So if I wrote that rule out for this scenario, it says Vn equals VO, so which is in this scenario 18,500 minus n times d, which is that d was that 1850. So when I'm trying to work it out, and I want that value to be 0, so when is that value 0? And then I pop the rule in. And then what do you think you do here?
Replace n.
What do we want to do? We're trying to find n. Solve. So remember, as I said, don't write the solve on your paper, but that's what you need to do in the calculator. So you do solve, and then you'll end up with that n equals 10. Okay, so therefore, how long will it take it to depreciate to 0? 10 years to be 0. Now, what you need to also start doing with finance is think practically, okay? Because you will then pick up if you've accidentally make a mistake. So a 10-year-old car to drop down to 0 when it began at 18,000, that seems reasonable, yeah? That seems about right, okay? So we're pretty happy with that answer. Okay, so the following recurrence relation, so remember they're telling me it's a recurrence relation because they've written it like this with the VO and the VN plus 1. Can be used to model, and remember, always underline this stuff so you know what part of the formula sheet you've got to go to. So it can be modelled by the flat rate depreciation of office furniture purchased for 3,700. So yep, there's our VO at a flat rate of 7% per annum or per year. If in the recurrence relation, VN is the value of the furniture after n years, they will always tell you that. They're explaining the letters. All right, so it says use the recurrence relation to find the value after 1, 2, and 3 years. So we want V1. So V1 equals the initial minus 259, which equals 3441. Then we have to show that V2 is that number minus that number, which is 3182. And then we show the last one, V3, is the one before minus 259, which is 2923. Okay, so that is me using recurrence relation to show the value after 1, 2, and 3 years. Now, part B, it says how long will it take the furniture to depreciate to less than $1,000? So we want to know pretty much when it'll hit 1,000 and therefore be less than that. So here's another time where we might want to use the nth rule. So the nth rule, looking up at the top of your page, is Vn equals, so I'll just write the generic one so you can see what it is. And then in this scenario, VO is 3,700. And what's the D? 259? Yep. So I can read that off. So then we want to know when it's 1,000. So when will this formula give me 1,000? So if I write that out, what function are we going to use on our calculator? We're going to use solve. And the reason I'm putting it in a different color because I don't really want you to pop it on that part on your exam paper, but I do want you to know that's how you're finding it. So n equals 10.4. So in this case, if I went to 10 years, the value wouldn't be under 1,000 yet. So what do we have to always do? You round up. So therefore we're going to say after 11 years, it'll be less than 1,000. Okay, now we're going to look at another type of depreciation, and it's unit cost. And it is still an arithmetic. So it's still an arithmetic like sequence where you're still minusing same amount. The only difference with this one, with flat rate, it was a percentage of the cost of the actual item. With this one, they're saying every time you use it, it takes away the value of the machine or the item. So for some things like, probably shouldn't have said lawnmower before, but with a lawnmower, if you got a brand new lawnmower and it sat there and it didn't get used, it would still probably be worth the same amount. The second you start using it, it's going to be depreciate. Now, if I use my lawnmower more than someone else, it's going to wear out. So this is what this type of depreciation is. Okay, so other scenarios where you use it, they often like the hairdryer, like every time you use a hairdryer, that seems to one. Another one is sometimes a caravan, like once you start driving it and the Ks it gets used, they'll say that and things like that. So let's have a look at how it works. So we've got our formulas here again, where the first column shows us the recurrence relation set up. Now, it looks very similar to flat rate. The only thing is how this D is found is different. So with flat rate, it was percentage. With unit cost, they're going to tell you how much every use it costs, and that's what it's going to be. So it says over here, sometimes they tell you it, and sometimes you have to work it out. And so this formula, don't worry too much about that. That'll probably come more in play next year. But this is that, and here's our nth term. The middle one is our nth term. So let's have a look at, anyway, this scenario. So a car is purchased for a price of $32,000. So there's my VO, and it depreciates using the unit cost. So you've got to highlight that so you know which one you're using. So unit cost, and it says that it drops $150 per 1,000 kilometres. So this is pretty much telling us the D value there. So it wants us, the first one, it says, state the recurrence relation for the unit cost depreciation of the car, where VN represents the value of the car after N thousand kilometres. So because they're going to, instead of saying every kilometre, they're just rounding it to every 1,000 kilometres. But it's okay because they want the rule to be every 1,000 kilometres too. So you just do it the same. So let's have a look. We've got to write a recurrence relation. So when we write a recurrence relation, we write the VO, which was 32,000. And then we've got to write the VN plus 1 rule. Now up here, you can see it's telling me. Now, if it's highlighted, that means I'll have to write something else, not the D. I'll have to write what actually D is. So we'd work that out. It was 150. So there's the recurrence relation. And we're saying that's per 1,000 kilometres. Okay? So then we get asked, it says use the recurrence relation to show the value of the car after 1,000, 2003. So it's still sort of like saying V1, V2, V3. That's because we're saying the rule is for every 1,000. So what we'll do, we'll say V1 equals the initial, so 32,000 minus, what are we saying? 150. Yeah, which equals 31850. Then we're saying V2 equals 31850 minus 150, which was 31700. And then V3 equals 31700 minus 150, 31550. Okay, so we got that. We've done that one. And then it asks us, it says, how many kilometres is the car expected to travel before its value depreciates by at least 1,000? So we just got to be careful with that. They said depreciates by at least 1,000. So that means if it was 32,000, and they want it to drop down by 1,000, they really want to know when it is 31,000. It's sort of be careful with the words there. That was a bit tricky. So it says how many kilometres would have it had to do. So we're trying to find n when it drops to 31. So you could do, we were very close up with our thing. We're up to 31 here. You could either keep going recursively and see that it's after 7 years, or I'm going to try show you with the nth term so we can practice it. So using the nth term rule. So we would write that one out. So that one would be Vn equals VO, which was 32,000, minus n times 150. Okay, I want to know when it's going to be 31,000. So I pop that into the rule. I'm going to use solve to find out what n was. So solve, comma, n. Oops, sorry. And I get n equals 6.66. Okay. So it wouldn't be there yet. So therefore, we're going to say when n equals 7. So remember though, this was 7 per 1,000. So actually, how many Ks has it actually done? 7 what? 7,000. So just be a little bit careful. So we'll just write therefore. That's the symbol for therefore in shorthand. You'll see lots of mathematicians do that. Therefore, after 7,000 kilometres. Let's do this one. So an office printer purchased for 9,200. Here's the VO. Depreciates at a unit cost of $15 per 1,000 sheets. So the unit cost is very important. I really want you to start practicing highlighting that because it will make it a lot easier. So there's the D. Now it says A. State the recurrence relation for the unit cost depreciation for the office printer, where Vn represents the value of the printer after n hundred thousands. They're writing that here because they gave us the D like that. All right, so off we go. A recurrence relation means I have to state the VO, and then I have to state the n+1 rule, which would be Vn minus $15, because that's what the D is in this scenario. So remember, that's per 100,000. Okay, so then it asks me in part B, using recurrence, find the value after 100,000, 200,000. So this is like V1, V2, and V3. So V1 would equal 9,200 minus 15, which equals 9185. V2 would equal 9185 minus 15, 9170, and V3 equals 9170 minus 15, which equals 9155. Okay, and then it says after how many sheets, I'm going to do C over here, how many sheets can be printed for the office printer value to depreciate to less than 9,000? So this is where they want the value. So they want Vn to equal 9,000 or be less than that. So I'm going to, let's do the nth term rule. So the nth term rule states that you write Vn equals the VO, which is 9,200, minus n times D, which is 15. All right, we want it. Now, if it wants to be, we want it to be...
Is yours frozen again, Miss? Or?
No. Oh, yeah, it is. All right, so we've got the nth term, the nth rule, and we want this to equal 9,000. So we pop that in there. Okay, and then we can use, okay, so we're going to use solve and comma n, and we find out that n equals 13.33. So we know, what are we going to say therefore?
N
Yeah, n equals 14, but they're asking me how many sheets can be printed. So n was 14 per 100,000. So how many? So it's actually, you're going to times 14 by 100,000, which is actually going to be 1,400,000, yeah, sheets. With a photocopier, that would probably make sense.